Hi everyone, Alex Tardy here, National Weather Service Office in San Diego. While it's getting hot outside as I make this recording, and you can see behind me on our weather.gov page, we're here to talk about a climate update, discuss some weather extremes that we've experienced over the past year or so, and of course talk about El Nino and if and how that will affect our weather coming up for 2023-2024 winter season. This will be updated at least every month as we go through the fall and early winter. Thanks for joining. If you find this presentation valuable, let us know with feedback. And if you're only looking for certain parts of the presentation, feel free to fast forward through on YouTube. Thank you, everyone. Okay, like I mentioned in the introduction, we're going to talk about some recent weather extremes, how that plays a role in our climate and why it's important to look at these, especially when you start talking about predictions 3 to 4 months in advance. Some of those weather extremes, record snow, record rainfall, and associated flooding and damage, and even a tropical cyclone Hilary. The water year has ended, and here's how the numbers stand. At most of our climate locations, 30 years of data to become one of those, we can see that there are several that are top 5, including number 1, Palomar, number 2, Big Bear, and number 2 at Oceanside. These are climate sites that are indicating the wettest or second wettest water year on record. Take a look at the location nearest to you and also consider the averages, how some of those are more than double or 2 seasons in one. Here, let's take a close look of the most recent monsoon 2023, July through September. We can see temperatures were very warm inland areas and the Southwest. In some cases in the Southwest, record warmest period on record, July through September. Those areas were also dry, very dry, top 10% in the Southwest, Arizona, Southwest Colorado, New Mexico. And in some areas, record driest as shown here. On the contrary, Central Southern California was much above average, largely thanks to Tropical Cyclone Hilary that moved through August 20th. Let's look closely at July 2023 and see the magnitude of that particular heat wave that lasted most of the month. An anomaly or unusual upper level high pressure was centered over Southeast California as shown here for the majority of the month. That resulted in record hot temperatures. In fact, the hottest month on record from Las Vegas to Palm Springs to Phoenix, Arizona. And this is shown up in the rankings on the left-hand side. Remarkable heat wave, July 2023. It's been a trend over the past several summers. 2020 and 2021 were 2 of the hottest on record and very active wildfire seasons across California. Notice that upper level high pressure persisted in the Pacific Northwest during those summers, and in 2023, it expanded across Canada, where there also were a lot of wildfires earlier this year. But notice the heat dome that redeveloped and established itself over Texas and the Southwest in 2023. If you look last year, 2022, what was remarkable about that year, it was a near record-breaking monsoon season in terms of being wet. The battle between cool air in the eastern Pacific or an upper level trough and upper level high pressure focused all that moisture across Southern California. If we take a look at the heat wave that occurred last year, late August and early September 2022, this heat wave also was number 1 across Southern California, most of California, and even the Great Basin area, where temperatures averaged between 6 and 12 degrees in that 2-week period above normal levels. In fact, the hottest day in California history on record, hotter than 2006, was September 6, 2022. So very hot summers have been a trend, and individual heat waves within those summers also a trend, such as 2022 in early September, and then July in 2023. Two summers in particular really stand out for prolonged heat waves, not just a 1-month period, but several months. 2020 and 2021, also very active record-breaking wildfire seasons. The dark red shaded areas were record warm during the periods shown here, the majority of the summer. So the red means that mountains, valleys, coastal and desert areas had temperatures never seen before during those periods in back-to-back summers. If we look at this past year, July and August 2023, we can clearly see the desert Southwest wasn't just dry, in some cases in dark red, record dry. And in central Southern California, not just wet, but record wet, especially August with Tropical Cyclone Hilary. And again, this was after 2022 was very wet in terms of regular monsoon. So you had a near record wet 2022 in the desert Southwest, and you had a near record or even record dry in 2023, parts of Arizona and New Mexico into Colorado. And here are just some of the impacts from Tropical Cyclone Hilary. San Bernardino Mountains and Riverside County, Coachella Valley. Riverside could be the most expensive natural disaster on record, $135 million in damage collected from the flash flooding, from the mud, from the debris that wreaked havoc across that region, as Tropical Cyclone Hilary made landfall in Southern California as a tropical storm. If we look at the temperatures in Palm Springs or the Coachella Valley, July turned to be the warmest on record. But 1 month later, one of the wettest days, number 5, occurred on August 20th with Hilary. If we look at any month, July came out as number 1 in Palm Springs for any month as the hottest. And if we look at any August, it came in second place for the wettest August on record, all within a 1-month period. And it wasn't just a Coachella Valley. Across Southern California mountain areas, we saw, thanks to the rain from Tropical Cyclone Hilary, which came across as a tropical storm strength, Big Bear, Idlewild, and Palomar Mountain were all top 5 wettest for any August. And those are areas that do experience thunderstorms and heavy rain during the monsoon and summer months. The water year, which will include the monsoon, include the Tropical Cyclone Hilary rainfall, and of course the 13 atmospheric rivers, came out to be 1.5 to 2 times wetter than average, as shown on the right-hand side, central Southern California. And in some cases, areas were the wettest on record in central California, including the Sierra Nevada. And also, you can see most of central Southern California in the top 10% for wettest. And now you'll see why this is important to look at this. The past El Nino years, when you put them all together, are shown on the right-hand side. Last year on the left-hand side. The composite of the past El Ninos for California and the Pacific Northwest looked like an El Nino season in terms of precipitation, except it wasn't an El Nino. It was a La Nina. Here's what the average jet stream looked like in 2022-23. Take note of the upper level blocking or ridge that's resulted in the really warm temperatures in the North Pacific in the ocean. Note that that shifted a little bit to the west, and that allowed the door to open up for a persistent, not just one storm, but persistent weather pattern between November and March, carving across California with a direct path of most of these storms right into central California, as shown here. Two anomalies, two areas of unusual weather, cool and warm, driving the jet stream weather pattern. If you look in the heart of the past winter, 2022-23, you can see when most of the storms occurred December through March, it was record-breaking for Central California, as shown here. And even top 10 extended into Southern California. While it was dry in the Pacific Northwest, considerably drier than average. Why is this important? Because the location and persistence of the jet stream is what makes our winters, whether we're dry, average, or above average wet. These are photos taken during a National Weather Service storm survey, January 16th, showing the widespread flooding in the Mission Valley area, in flood-prone areas and areas not used to flooding at this degree. The atmospheric rivers that occurred in early to mid-January and across the entire state of California during the winter 2022-23 are shown here. You can see a concentration of them in Central California, where several were strong, and another concentration in Southern California. So this time last year, this is what I would have presented. A La Nina, full-fledged La Nina, blue-shaded, colder than average, for the third year in a row. And you can see the warm anomalies in the northern Pacific from the past 3 years of upper-level ridge, warming of the sea surface temperatures that are still present today, but were there last year. What is different here is the region where we track El Nino and La Nina was a full-fledged La Nina in early October of last year, the cold phase. One of the things that came about last winter wasn't just rain, it was the record snowfall. The snowfall we've never seen in history based on the data that we have, and the fact that snow reached all the way down to coastal cities. Didn't accumulate, but it snowed. This record-breaking snow, again, was the result of that blocking weather pattern that shifted to the west a little bit. So instead of drought, we had relentless cold combined with atmospheric rivers bringing this unprecedented snowfall. I want to share these photos to remind everyone that the snowfall was not just Mammoth Mountain, California, where they had 715 inches of snow, most ever recorded there, but it was Southern California as well, as shared in these photos in our mountains. The historic snowstorm looked like this when you plotted it on a map. In a 1-week period, snowfall was between 60 and 130 inches across our mountain areas. Remarkable snowfall. Snowbanks that were so high you couldn't see buildings and entrances into areas. On this water.weather.gov website, you can see another view of the 2023 water year. Percent of average, 1.5 to 2 times wetter than average. All those areas that you see the blue shaded, with dark blue up and over 2 times as much compared to normal precipitation. Now, the good news about last year with the atmospheric rivers was that we were able to predict them very well in advance, 6-7 days in advance, as shown here. So the predictability, even though the events were extreme, was really good within 10 days. Keep that in mind. However, the predictability beyond 10 days, here this example shows the low predictability skill or high uncertainty in those type of forecasts. What was the actual forecast for the water year? Well, for the core of the winter, December through February, where most of the precipitation occurs in California, you can clearly see here that the forecast was below average in Southern California and above average temperature. The below average precipitation forecast was opposite of what happened, with 1.5 to 2 times wetter than normal. You can see in the Pacific Northwest as well, areas that were drier than normal, the forecast was opposite of what actually occurred during the core of the winter season where we see most of our storms. If you look again at the water year last year, I want to emphasize how wet it was and record-breaking wet it was, and how opposite that was portrayed in the actual forecast. So predictability beyond 10 days has not improved. In fact, if we look at the probability that was issued last fall of a normal winter or average winter, that value was pretty low. In the middle of your screen, you can see it was 30 to 40%. The probability for above average, or even 1.5 times average, was even lower. That was down to 10 to 20%. So we saw how poor the seasonal forecast was December through February. Now during the season and within the season, how well did we do? Well, on December 9th, this forecast was issued, and it started to capture the unusual or above average probability for wetter than normal in Central and Northern California. While it missed it for Southern California, it was a much improved 1-month lead time, or weeks 3 to 4 forecast for California. Now let's look past different El Niños and La Nina. One thing to note is the wettest year in the Sierra Nevada is the La Nina, 2016-17. The Super El Nino of 2015-16 was dry for Southern California. And the most recent Triple La Nina was dry up until the last year, which was very wet. It's been a long time since we've had an El Nino of strong category that has actually been wet, and that would be 1997-98. I think it's important to look at what actually happened with the most recent strong El Nino, 2015-2016. Between November and March, not only was Southern California relatively storm-free, it was much drier than average. The driest location in the United States, as shown here in that period. Why is this important? Because when we go into another strong El Nino potentially, we've got to look back at how the predictability of these events is very, very low. We can't blame it on El Nino in 2015-2016. Why not? Because it was the strongest on record. It was there. It was observed. It lasted through the entire winter, as shown here. So what went wrong? Why are we having El Niños that don't behave like we once thought? And why are we having extreme precipitation in years when we don't expect it? Well, let's look again at last year compared to the El Nino average. The right-hand side is what we expect with all El Niños wetter than average in much of California and the Southwest. And that's what we saw last year in a La Nina. Now, if we look even closer, 2015-2016 was much like a La Nina. Wait a minute, I'm confused now. Yes, they swapped roles. The strongest El Nino on record in terms of precipitation behaved like we see in an average La Nina. What we need to remember is El Nino, La Nina is the ocean, and precipitation is the atmosphere, and they don't always work together, certainly as we expect them to or thought they did. Let's look closely at all these strong El Niños. That means 1.5 degrees Celsius or higher over a 3-month period during the winter. On the left-hand side, you can see there is a strong signal across California, including Southern California, of wetter than average. Now, when you remove 1982 and 1997, 97, 98 was the last strong, other than 2015-16, it was the last strong that was very wet. You can see that when you remove those 2 years, it does disappear in terms of the strong signal in the southwest, though it remains weaker but still there in much of California. I mentioned 2015-16, the strongest El Nino on record, ranked at 2.6 Celsius. Now, what went wrong was the jet stream was shifted to the north over Seattle persistently. Upper level low pressure, or that anomaly in purple, was semi-permanent. It was there for a long period of time. Opposite of a blocking upper ridge, we had a blocking upper low, and that forced the storm track with numerous storms to go up into the Pacific Northwest, missing most of California during the winter. So the El Nino changed the jet stream and enhanced it, consolidated it, but it didn't point it into California. Okay, so now what are we looking at? Well, this spring we rapidly developed into an El Nino, or the warm phase, so getting rid of 3 years of La Nina cold phase. The storm track of last winter was shown overlaid on this map as well, and that turned over the water, bringing in cooler conditions across the coast of California. But the warm water that was present last year and the year before was still present this spring in the northern Pacific, despite that storm track that went up and over a lot of that warmer water, allowing that water to become even warmer. So 2 things happen. The El Nino developed in spring, and the persistent storm track lingered into early June across the west coast. Let's take a look at current conditions in the Pacific Basin, starting with the El Nino zone along the equator. Well-established El Nino, warmer than average, currently here in early October. When we look in the central and northern Pacific, we see large areas of also warmer than average, warmer than long-term averages. Those are the result of the jet stream being so far north over the past several years, including the drought period. So there's 2 major things going on: the well-established El Nino across the equator and large areas of warmer than average water or marine heat waves in the central, western, and northern Pacific Ocean. So if El Nino is around and it's well established and intense, at least moderate strength, then why aren't we expecting really wet upcoming months in 2023-24? We've got to keep in mind that past El Ninos and La Ninas have not resulted in precipitation that either we expect or have seen historically. Some examples are shown here. One of the wettest years on record in the past 10 was the La Nina. One of the driest years on record in the past 10 was a La Nina. As you can see, these extreme years are dominating and overshadowing some of the other influences, such as La Nina, El Nino, that we once thought we had a good understanding of. Now, there's a lot of numbers here, but what's important is to look over the past 10 years or so. The wettest years in Southern California have been La Nina. 2010, 2011, 2016, 2017, and now 2022, 23. And the only year that was wet and was an El Nino, wetter than average, was 2018-2019, which, by the way, was a weak El Nino. It was a weak El Nino that year. Again, a lot of numbers, but what we should point out here in some of these mountain locations, especially the green, the Super El Nino, strongest on record, 2015-16. Precipitation those years was much below average. If you look at the past water year, 2022-23, locations are double and even triple in terms of being wetter than that record El Nino of 2015-16. These are important numbers to consider. You can look at other years as well. The last El Nino that was wetter than average, shown here, 2018-2019, but also the very wet 2010-2011 and very wet 2016-2017, which was above average as well. And those were both La Ninas. Now let's look at some seasonal and sub-seasonal, so within a winter type of extremes that have occurred lately in Southern California. Let's take a look at an example of December 2021 within a season or a water year. This month was extreme precipitation. December 2021, rainfall and snowfall was 2 to 3 times above any December on average. Snowfall across Tahoe was relentless, and rainfall from several significant storm systems and atmospheric rivers listed here for December affected Central and Southern California. In fact, the month of December 2021 in the Tahoe area and in the Mammoth area was top 3 snowiest on record of any month in December 2021. Only to be followed by one of the driest periods on record in the red shaded, the driest period on record between January and March. All of the winter came in the month of December, and none of the winter came January to March 2022. Very extreme, not year to year, but within the same year. The precipitation across California was so dry, some areas between January and March saw nothing in terms of rain or snow. After one of the wettest and snowiest Decembers of 2021 occurred. So what happened? Similarly, we had a block in the Northern Pacific. That same block that brought record snow in December 2021, the same block that brought record precipitation just this past year, 2022-23, and the record snow in California as well, shifted. And it shifted and it closed the door on the storm track within the same season as shown here. January through March 2022 was so dry, some places in California didn't receive any rain. These are critical months. These are the wettest months on average, January through March, with February in most places the wettest month on average. So the snowpack dwindled. It went from 160% of average, 1.5 times on January 1st, down to 18% when this was shown in May after this record dry period, January through March. You might be wondering how long this block or upper level ridge steering the jet stream way to the north, resulting in the most recent drought years, how long it's been around. Well, we can trace it back to at least 2019-2020, and it lingered all the way through the next 2 seasons as shown here, even though it did have shifts. In 2019-2020, it was just far enough to our west that Southern California remained somewhat active and had some significant storms. However, Northern California was blocked, directly blocked, all 3 years. In water year 2022, let's take a look at some of the atmospheric rivers. Only a few reached Southern California and even Central California, where the majority were concentrated across the Pacific Northwest, like fish going after food in the water. And this resulted in yet another dry year for California. If we look at the prior to 2020, 2021, everything was shifted into the Pacific Northwest, almost like fish going to food. Now, in 2021, a lot of the precipitation just missed California. In 2020, it was a little more spread out across the state, as shown here. Both of these maps show the importance of the storm track, the persistence of the storm track, and it has to be around more than just 1 month to make it a wet year or a dry year. Okay, now are you ready for the outlook coming up for 2023-24? After learning all that information, you might be able to better understand why there's great uncertainty. We are currently in an El Nino. We showed that on the satellite image earlier. We can see here the latest weekly analysis is actually in a strong El Nino, but overall over the past 3 months, a moderate phase El Nino, the warm phase. So that's easy, right? Now we expect a wetter winter, not so quick. We just went through everything about some of the extremes within seasons and the extremes year to year and the blocking weather patterns. So for the month of October, we do expect some precipitation. Currently, we're in a heat wave. Overall, warmer than average for the month of October, and overall, a slight tendency to be wetter. Slight tendency. When we look at our latest models, computer model projections, and we start looking at between November and January, so beyond October, here's some of the things we're seeing. We're seeing most of them indicating a dry start to the winter. Most of them a dry start to the winter in California. And that's a factor in our prediction. If we look further out between December and February, we start getting a little signal of wet. More of them are showing wetter than average, not just average, but wetter than average for parts of California. When we go deeper and we look at it even closer, we can see the fall and early winter, upper left, drier than average signal, then a slight wetter than average signal December through February, and then we finally get into a wetter than average signal in January through March, as shown at the bottom. So finally, that brings us to the latest forecast, which again, we'll update this each month. And it shows only a slight probability in the green shaded, 30 to 40% chance of being above average in Southern California for the heart of the winter, December through February. But wait, you're saying it's green, but the green is only 30 to 40% chance. So there's nearly an equal chance of it being an average winter or even a drier than average winter. When we look at temperature, there's no signal at all. Because of everything we've looked at, the relationship or the lack of relationship between the current El Nino and precipitation in our jet stream, this is why the forecast is high uncertainty. Now, we do expect the jet stream to be affected and changed and even maybe even enhanced like we saw in 2015-16, but where that will land the majority of storms remains uncertainty. High uncertainty with a slight chance of above average for Southern California. On the same type of map, I give you the same view, December through February, in case you wanted to look at it with more of an Earth type of view. Okay, The next update will come out in late October, early November. Meanwhile, we hope you enjoyed this presentation and learned something and better understanding the high uncertainty of the precipitation forecast for 2023-2024. Thanks for following.